We're going to talk about some brief basic considerations about belay theory when we're getting started, getting ready to contemplate, learn, and implement all these things that we're going to learn or already know about rope. In regards to belay systems, whatever belay device or rigging out implement that you utilize, you want to ensure that that belay device and the belay applications you're utilizing meet a whistle test. A whistle test implies that at any given time I can let go of that system and it's going to secure that rope and the potential travel or fall of that load. There's a little bit of controversy in regards to that in the field. So one of the favored or often seen applications that we'll see with belay devices in rope rescue applications sometimes is a munter hitch. When utilizing a munter hitch as a belay component, it's important to understand two things. Number one, it's designed for a 300-pound load. So don't use it in applications where you potentially have a rescuer and a victim in a pick-off application or a load that's going to be in excess of 300 pounds in theory, design load. The second consideration is you've got to understand that if you choose or elect to use the munter, it does not meet the whistle test. So if you're operating a munter and you let go of the ropes, that rope will continue to progress through that carabiner that it's rigged into, and there's nothing to stop it. So you're never going to be able to secure that load. You have options, whether it's a tandem Prusik belay, a 540, an MPD, some Petzl components, whatever device you utilize, make sure that you are fluid and proficient in its operation, and that before you ever allow a rescuer to progress over the edge, that you have given it a pull test to ensure that it is activated, that it is rigged appropriately, and that it will secure the load if we have any sudden fall. The other theory that's an important theory, I think, when operating belays is to ensure that we have as little fall factor built into that belay system as possible. There's also some controversy about fall factor and how it truly correlates to static rope, since it's basically a dynamic rope consideration. In fall factor, we're basically contemplating a coefficient of 0.25. How that loosely correlates to us in the field is 1/4 the length of the rope and the potential fall. So it's basically an equation that originates around length of rope, potential fall of victim, and if those two factors are in excess of 1/4 of the length of that rope in regards to the potential fall, we're going to get a resultant factor that is greater than 0.25. If you arrive at that answer by rule of thumb, it's typically agreed upon within the rope rescue world that you're going to convert from a static rope application to a dynamic rope application. Under recent years, that theory, that theology, that scientific testing, and so on and so forth have come under a lot of scrutiny, and there's some varying viewpoints along those lines. Without getting into the specifics of those components, I think it's important with a common sense type of approach to understand the theology behind that theory and glean from it what is useful, applicable, and increases the safe operations that we implement on the rope ground. So I think the 1/4 rule of thumb has some loose applications, but the real application from it is understand that the more slack you have in the system and the greater potential free fall you have of the load, the more catastrophic the results are going to be on your systems. So try and keep the slack to a minimum. The best way to do that when operating a belay device, whatever it is to try and pull Z's. So when we pull Z's, we fix our hand on the rope, we're going to ensure that we're pulling out a segment of rope that accommodates the travel of that load or of the rescuers as they're descending down rope, or if they're coming up rope, we're simply pulling on rope and keeping it as taut as possible to that belay device. When we pull those Z's, keep them at a minimum, keep the rope taut in your hand, and keep the rope secured up towards the anchor side, ensuring that that basic element of rope that's forming that Z is the maximal amount of slack or potential fall factor, if you will, that you're going to potentially allow to become absorbed or impact loaded if we have a transfer from the main line to the belay line in a catastrophic type of event. So that's one of the primary considerations about belays. Ensure that you use an appropriate device. ensure that it meets the whistle test, and ensure that you're managing the slack within those systems appropriately. Communications about belay devices are also an important component.
Safety set.
We're advocates of using two basic commands: slack the belay or tension the belay. You don't want to have an individual or a rescuer call out, take up slack on the belay if he wants it tensioned, because you may have parties on scene or rescuers on scene who will only key in on that verbiage of slack and start playing rope out of the belay. So we like to just use two clean commands of tension the belay or slack the belay, with the emphasis being on the words tension or slack. Both of those will help manage that line appropriately to ensure that we are minding that slack issue or that potential fall factor component effectively. The other issue gets a little bit into the anchor segment that we talk about more in depth in the anchor theory component. But with our belays, remember to always try and keep them as the most direct line to the loads, and that in regards to our anchors, as well as directionals, as well as edging components. So try to avoid directionals, try to even avoid high directionals, try to edge pad appropriately with edge protection that's not going to increase friction on that rope system and create as smooth of transitions as possible. Use those appropriate belay devices and make sure we're managing and minding them well, ensuring that we've done effective pull tests, that they're rigged appropriately, and they're ready to safely keep an eye on our rescuers and our victims.